this lecture, we will see some solutions that allow to enhance natural lighting in situations in which, even if windows are sized to make the most of natural light, it may be insufficient or poorly distributed. In this regard, the main systems to better control the natural light are Venetian blind, light shelf, and anidolic ceilings. Venetian blinds, which are the classical systems to control the sunlight, in fact, can also be used to redirect it. The blades may be flat or curved, fixed or movable, solid or micro-perforated, and can be placed outside to achieve a better solar control, inside or in the cavity of double glass. In any case, in order to redirect the light, they must be reflective in the upper part. By adjusting the inclination according to the position of the sun, the blades reflect the rays onto the ceiling, which must be light-colored, obtaining a diffuse illumination. Perforated blades with small holes, moreover, allow keeping inside a reasonable illumination level, even if they are completely shut and some view outside. A more advanced system consists in the so-called light shelf, which is a well-established way to facilitate the penetration of light into a room and to protect from direct glare. The light shelf is generally made of a horizontal shelf arranged on the outside and or inside of the windows in its upper part. The light shelf must be placed so as to avoid glare and maintain the view outside. Light shelves should be designed specifically for each orientation of the windows, room configuration and latitude. Orientation, position, type and depth of the light shelf is always a compromise between the needs of natural light and sun protection. The minimum depth of an external light shelf is determined by the shading requirements. For the interior light shelf, the limiting factor is instead the glare. The depth required is greater in the case of east and west facing facade, and it varies with the orientation. In facade oriented within plus/minus 20 degrees of south or north near equatorial latitudes, the external light shelf should have a depth between 1.25 to 1.5 times the height of the ribbon windows above. While for more than plus/minus 20 degrees of south or north should be extended between 1.5 to 2 times. For room facing south or north, according to the sun path, roughly the depth of the internal light shelf may be equal to the height of the ribbon windows above. If the optimum depth of the external light shelf is excessive in relation to the other needs, the same results can be obtained by recessing the windows below. With this type of solution, the contribution of natural light can be further increased by appropriately tilting the sill. The depth of the internal light shelf can be extended so as to always intercept the direct radiation through the windows above. At low latitudes, if the south or north facing light shelf is tilted upwards, the contribution of natural light increases, but the exterior part must be extended for providing satisfactory windows shading. The optimum tilt angle at latitudes near the equator depends on the ratio of x over h. For example, if h is 0.5 meters and the width of the room x is 3 meters, the optimal tilt angle is almost equal to 40 degrees. The use of a light shelf allows natural lighting even when, to avoid glare, the glass area below is protected with a shading device. For southeast and southwest or northwest and northeast facing facade, the resulting depth of the inner shelf may be excessive. In this case, a series of smaller shelves, properly spaced, can be used. An alternative solution consists of reflective blades, fixed or mobile, on the inside or outside of the glass strip. In this case, the outer shelf has the sole function of solar protection for the underlying glass. The effectiveness of natural lighting with a light shelf can be increased appropriately by curving the surface hit by the sun's rays. The characteristics of the upper surface of the light shelf determine its effectiveness, both in this and in all other configurations. The surface must be white or reflective, and periodic maintenance is necessary to avoid losing its features. Finally, systems with anidolic sealing are based on non-imaging optics and take advantage of the optical properties of compound parabolic concentrators to collect the diffuse light from the sky and convey it into less illuminated part of the room. Outside the building, an optical anidolic concentrator captures and focuses the scattered light coming from the highest part of the sky. A light pipe arranged in the ceiling carries the light in the back of the room. In correspondence of the outlet of the duct, a parabolic reflector distributes light in the bottom. On a clear day, the penetration of direct sunlight can be controlled by a roller blinds that unfold above the outer glass of the opening. Of course, after an initial preliminary design, it is advisable to optimize the described system using simulation models, which is the only way to predict their effect and performance with reasonable accuracy.